I write a compiler for a small imperative programming language called Elna. The compiler is already self-hosted, so it is written in itself, but it isn't finished yet. So in my code, I only use the features that are already implemented, and after implementing some features, I can start a new stage and use these features in the next version of the compiler. And now I'm going to do some work on the tokenizer. It will be almost cleaning up and probably just moving around the code so that the tokenizer is a bit more usable, so to say. The tokenizer types have this prefix Alexa and the functions too. And the first thing, I want to rename this function, so it is just called Alexa initialize. Actually, we can also rename these procedures. I think that they just initialize the tables that are used for the lexing, yes. So we rename this to Lexa transitions. These functions modify this Lexa state variable that is probably a global variable of type Alexa cursor, and I actually want them not to be global anymore. We have just to find the places where this global variable is used, and then we can pass a pointer to this variable to the functions, and probably we can just start with this initialize function, Lexa initialize. So we get the source code here and assign it to the Lexa start and end position. Actually, Lexa state start. There should be more places where I assign these variables, but here they are different, and here I reset or I skip the token, so I set the start of the next token to the and of the previous one. Okay, this is the only place where both start and end are assigned with the same point. What does Lexer state has besides? So it is this cursor. It has start, finish, and it has state. And the state, what is the state? The state is actually, okay, I see. So it is an enumeration, and it says which token is currently parsed. Not which token, but a state in a state machine. Actually, I think that I do not need to allocate this cursor on the heap. I probably just can create a local, or we can use the global variable first, and we can replace it later with a local variable. So that would mean that I should pass this state as the first argument to this function. So we pass the Lexer state to it, and I will call the variable just cursor then, and its type is Elna Lexer cursor, I think. I hope I can still compile it. The one reason I want to modify the tokenizer bit so that I can collect more information. For example, my parser doesn't collect things like search position of tokens, and therefore I do not really have useful error messages, and extending the tokenizer will help with that, I hope. And now we do not want, and it is not the type itself, but it is a pointer, and it would mean that instead of Lexer state, I can just write cursor and dereference it, and here the same. Okay, and it seems to work. So let us look for further places where it is used. For example, here in the next transition. Let me split the screen so I can look up the places in the code. Lexer get transition. Okay, it actually does some calculations. It doesn't need this global state, I think. Exactly, it gets current state as argument, but at least I want to rename this thing. So we need the state in this LNLX execute transition. And this is the only place where this function is called LNLX advanced token. And we advance the token until we see until our Alexa state is in the end position. Okay, and this function is then used in Alexa read token, and they actually also set the Alexa state exactly, and Alexa read token is then used in the parser. We will need to look for these parser functions first. Module declaration is probably the top parsing function, and we actually will need to parse the state to all parser functions, so that the whole visitor can access the tokenizer state. And we have then this compile function, and already this compile function needs this Alexa state. So let us begin then with the compile function. We pass the Alexa state to it, and we find it here and add the new parameter, and it should be a pointer. Then it can be passed to the module parser as its first argument, so we just pass it in here. I think that the function itself does not use the tokenizer. A cursor is probably a stupid name. I should have called it something like tokenizer state or Alexa state, but renaming is easier anyway, so we let it as it is for now. So compile, and now I want to go to this Elna parser, what was it, module declaration, and we add this variable here. I can just actually copy this thing here. That looks fine. Then this function calls further parser functions, parser type part, parser var part, and parser procedures. And we pass the cursor variable to all of them. And here we add the type in the top half So I'll parse the type part first, then we look for the variable part, and then we look for the procedures. And it is here. So let us look into the type parser. Skip empty lines, Lexo read token. So it calls the type declaration parser. And that's it, I think. Because the type part contains only type declarations. Then it parses a type expression, and it probably should also parse the type name. But type name is parsed inside of this function, and it only calls this type declaration. Type declaration is a bit, type expression is a bit difficult because type expressions are also used in other places. Not only in the type declarations. So I suppose that we visit now this Elna parser var part and look what parsers are called here. Probably type expressions as well, because we parse the type of a variable. Exactly, so it parses this variable declaration, we pass the cursor to it, and then look into the function declaration itself. It is here. Okay, and as I said, it probably just calls a type expression somewhere, exactly here. And the last thing is the Elna parser procedures. And here we call the procedure declaration, and that's it as well. So I pass the cursor in here, and we then go to the parser procedure declaration itself and add the parameter in here. That should compile. Procedure declaration, and it calls variable declaration as well. Now parser procedure declaration. Why does it call variable declaration and not variable part parser? Variable declaration, I think that I already Elna parser variable declaration. Exactly, I'm already added an argument here, so we can pass just this variable into this function, and after that This is the arguments, and it also parses a type expression. So this is the return type. Where do I parse the arguments? Declaration parameter read declaration cursor. Oh, so this variable declaration doesn't parse the local variables, but the parameters. Makes sense because the declaration is basically a variable name, colon, and the type expression. That would mean, so this will be done later. Here we have the var part again. And then I parse the statements, and we can actually add and probably a return statement at the end, and that's it. Let us begin with the statements. So we give it the cursor and find then the declaration itself, statements. Oh, it is another place, conditional statements. Well, this is a good thing about missing missing error handling, is that I can just add parameters and the compiler doesn't crash if the parameter isn't really used. So let us add the variables then here, for example, in this Elna parser conditional statements. Then we can add them here, and so conditional statements. Okay. Then we look for this if statement thing. It is used in here, so we need this variable in the Elna parser statement, and it is used here and here. Would be nice if I still can build the compiler. Okay, nothing is broken yet. Yeah, let us visit these single statements then. I would actually find this Elna parser statement in here in the bottom half, and I go then through all of these single statement parsers, and we begin with the go-to parser. Exactly. I think it doesn't call any further parsers. Then we have the if statement. I think I already handled it, so we can just pass the cursor in here. Then we have the return statement. And return statement parses in expressions, but we will handle the expressions in a moment. So then we have this label declaration. Label declaration, it's in here. Then we can pass the cursor in here. And then we have a designated as an expression itself. And we also has this assign statement. But this assign statement already has a parameter. So let me test the compilation. So let us go to this assign statement. Assign statement. Okay. This is the only place where the assign statement is called. So I just add the Alexa state and add it here as well, and it should do the trick. After we visited all the statements, I hope we can go back to the type expressions. That would mean we can actually just begin with this record type expression, so that we add the parameter here, and in the bottom half I will find where the proper parser is chosen. Record type expression, exactly here. And we need then the parameter also here, and everywhere the function is used. It is also used in expressions. It is used in the traits expression, so we probably should do the expressions first. Exactly, type expressions. So Elna parser type expression. Do we have the cursor here? Yes, we do. Then we have this pointer type expression, because it parses the nested expressions basically. And then we have array type expression. This is the same. It parses a nested type expression after the size specification. The most type expressions just call themselves. We already added this thing to the array and to the pointer and to the records, I think, as well. So it is Elna parser record type expressions, so we can add it here as well. And then we have this enumeration type expression. It should be pretty simple actually. It shouldn't call any other parsers, only the Alexa itself. So this should be fine. And then we have this named type expression. It should be also pretty simple parser that just calls the Alexa. Okay, I think that I could have skipped a few things in the record type expression parser. Doesn't seem so. Record. Exactly. So it calls on only the type expression, and here nothing else name. Okay, that's fine. And now we can go to the expressions, and the first one is a binary expression, I think. Array type expression. Okay, cursor, and we can add here the parameter where it is used else. So this is a call expression, and we can just add the parameter here. We should check first where it is used. So let us do this Elna parser call. It is used in this designator function. Okay. Parser designator, which is actually wrong. A function call is not a designator. But it works for now. Exactly, and then we can pass the cursor to this designator parser as well. Then the designator is used in the unary expression parser, but we can actually add it already. So, and that is it probably. We parse the simple expression, so we can parse at the parser Lexer state here, and then we have a bunch of functions for parsing of smaller things like variable names and numbers and such. We have here the reference expression with an argument. But we want to look at this call expression first. So it is called basically here. Here we have the cursor, and that's it. It actually should be called somehow as a statement, because a function call can be a statement as well. Let me check it quickly. So where do we have statement parser? Oh, it calls the designator. If it is an identifier, then parse a designator. So I parse the designator, and then I look whether it is an assignment or a function call, depending on which which token I see next, a pattern or an assignment. Okay, that's fine, I suppose. It actually means that we can just add the argument to this function, or basically cursor here, for example, and then we can add it here as well, and that should be enough. So let's go back to the designator. Type expressions are actually done. So let us go to the designator, and it has more calls. So we have Elna parser array access expression, and this is the only place where it is called. So we add it here and here. And then we look into the field access expression, and it is as well the only place where this procedure is called. So we add it here and here. And finally, let me do a quick test. And the next one would be this parser the reference expression. And then we still have this Elna parser simple expression. But it already takes a cursor, so we do in another test. That looks fine. And we had these simple expressions that should be done as well. I think this actually parses simple expression. Exactly. And we have here these. Let us find them here. And I can just add cursor to all of them. So boolean parser, then we have nil parser, then we have the traits. The traits could be a bit complexer than the rest, and we have this variable expression, but we can actually pass it in here as well. Okay, let us begin with the character literal. So parser character literal. Then we go to the parser integer literal. Then parser string literal. Parser nil literal, so here, and then we have variable expression and the traits. Parser trait expression, so we can add it in here. And this thing calls also a type expression. Okay. So we still have a type expression call in here. The procedure declaration, this is the return type probably. And we have one call here. Type declaration, what is it? Type declaration. Okay. And then here as well, variable declaration, okay. It's fine as well. That seems to be it. The next step would be to pass this cursor to the functions that are used by the parser, by the tokenizer functions that are used by the parser, so that these functions do not use the global state anymore, but a local variable, and then we can get rid of the global state. I want to save my current progress so that I can revert the changes if something goes wrong. For that, I look what files are changed and I just save the actual state, and then we can begin. So basically we have, for example, this Alexa skip token, and this functions just advances the token stream past the last read token. There are actually two things that should be done. First I want to rename this function. Actually, we can just add the argument as well. Let us try just to rename an Alexa skip token into an Alexa skip token cursor. And it doesn't work. So okay, for Boolean literal, for example, here is the thing is missing. Then Okay, it is called in this keep empty lines function. This one is actually that should be done before, but still we do not use this variable anyway. We can just use we can just add the parameter here and hope that it finally works. It does. And then the next thing that should be modified is actually this skip empty lines function. That shouldn't be needed at all. Skip empty lines it doesn't skip empty lines, it skips comments between statements and expressions. I haven't found a perfect way to handle the comments yet, because I do not want just to remove them from the parsed code, but I want to save them somehow, probably in the abstract syntax tree, but I'm not sure. I'm not yet sure how. So I have just functions that skip the comments for now until I find a solution that I really like. So let us then go through this skip empty lines function, and we also rename it without the underscore, and actually it is also called Ron. So this is the state where the compiler works, and skip token has already this this Alexa prefix, but skip empty lines should also get a prefix. So we just rename it into Alexa skip empty lines. And that's it, I suppose. So then we return back now. Oh, there is usages after the declaration. So we continue. Now we can go to this skip empty lines function. It doesn't use Alexa state directly, but an Alexa skip token does. And instead of Alexa state, we will use the cursor, start and finish. So it crashes. Okay. Okay, we've found the function that crashes. This is the Selena parts variable expression. If I try to assign this here, then we have a problem. So cursor is not set correctly here. Variable expression it is. And here we pass actually the cursor to it. Parser node. Okay. And it isn't used anywhere else. And apart, the simple expression is also called only once. And it calls this variable expression. And it is called from the parser designator. So designator is called twice. One time by this Elena parser statement, and the second one by this designator. By the unary expression, probably. And here we have our mistake, so this should be cursor. And then we call unary expression here as well. It is probably a binary expression part there. So now we want to write a cursor here everywhere. And now we can try again to change the code to the local argument instead of global variable. What was it? Skip token Exactly, and we said that we want here to have this cursor state is cursor end. It still doesn't work, so we still have our other places. Malloc, we do not call any parsers here. Let us call to the simple expression parser again. And insert it in here. Okay. So simple expression parser isn't always called with the proper Lexer state. Let us see where else it is called. For example, here. Yeah, actually the only place. But is it really the problem? What if I put a printf here? So I have here some debug code. I just copy it in here. And let me print the pointer in this cursor. Where will it be? Build valid stage 20 probably. CLS. This doesn't look fine. Can I always access its members? No, I cannot. Designated is called here and here. We can just move this code so that we can see which designator call actually breaks the compilation. This one for sure. What is with another call? If I add it here, will it break? Will it break as well? No, it compiles. Okay. But the output is not that correct. Yeah, because of this here comments. Now we have this designator, and here, so it is Elena parser unary expression called, and this unary expression is actually only called from here, where we parse the right side of the expression. Okay, let us see, can I use it here? No, I cannot. So let us look for the parser binary expression. There will be quite a few places where it is used. And we are missing the cursor here. Actually pretty everywhere. Okay. Then here and here. Yeah. Okay. Oh, now I removed the debug code. You do not need it. So parser skip. Nope. Alexa skip. Token cursor start cursor end. And now it compiles and probably passes the final test as well. So now we achieved what I wanted, and we can actually move to the next procedure probably. So we have this skip token thing. Alexa state is then modified by this Alexa read token. I actually want to modify this read token function more than this. I want that it returns, allocates and returns the whole token and not only the token kind. So this kind in the parameter, it is a pointer and it saves the kind of the token in the parameter, but I want to modify it so it returns the whole token, but I do not know if I want to do it now. Probably probably not. But this advanced token is interesting, and it actually probably does almost the same. Where is an Alexa advanced token used? So this is the declaration. It is called recursively and used here, and that's it. So there are just a few usages. Let us fix the type of this kind variable. So this kind is an Alexa kind, I think. Exactly. It is pointed to an Alexa kind. Looks fine. And this an Alexa advanced token, so I want to rename it. This is the one thing. I can actually add I cannot actually add this state parameter to this function without modifying. I cannot add the state parameter to the advanced token function without modifying the read token procedure. And this is not that great. Actually, why do I pass this kind as variable? So the kind in this function will be of course the same, so we can just replace the word here with the real kind. It actually executes this Alexa execute transition procedure, but we have to pass the kind the Alexa state to this Alexa read token function. And this read token function is used a lot. So I probably will do the token allocation in a separate pass, and here we will just add a new parameter, I suppose. Yeah, so I will rename it, and I will pass a cursor. We can actually pass it as the second parameter. No, I want it to be the first. We will do the same. I will save the current state so that I can revert if needed. And now we can rename this function, and we just add a new parameter in Alexa cursor, and it should be a pointer. And now we need to find all the occurrences of this function, and we need to rename it and add the cursor parameter to it. This will be quite a few usages, so it will take some time. But now it should be easier because the first step, introducing of this cursor variable in all the parser functions, is done and tested, and now it should be just adding the new parameter and it actually should just work. I could try to add the parameter with a regular expression, but well, I think I just go through all my code and just add it manually, because it still should be doable. This can be done later, but it should be, yeah, no, it cannot be done later. Okay. Okay. TIC. Why? Why does a TIC function calls a parser? What is all? Stage 19 CL CLLNA. This is LNA TIC enumeration value, and it really calls the read token and called it before. It should be a mistake. Let me write it down quickly so I look at this procedure in a moment. but this line can actually be removed. It is nonsense. Okay, that looks fine. And oops, this can be removed. And here we can go back to the stage 20. I just looked into the stage 19 and so into the previous stage, so because it is almost the same code and I can just see how it was before my current changes took place. Okay, I suppose that we can now modify this procedure itself. What was it? Elena Alexa read token. And it sets the state to the start state and finish state basically to the Alexa state to the same value. So it initializes the start state and sets finish to start, so advances their position in the tokenizer. Let us write with the cursor here. Exactly. And then I want to have this Elena Alexa advance token, and now we are in position to pass the cursor to this function as well, because it uses the global, this Elena Alexa execute transition use the global state, probably Alexa execute transition. Yes, this one actually modifies the global state. So we also need to pass this the cursor to this function, and Alexa cursor advanced token, and we pass it here, and then in this recursive call, so also here basically. And Alexa execute transition. Let us pass the cursor to it as well and rename it. So the kind here has the same type actually. So this is this an Alexa kind, and I think that this function isn't used anywhere else. And what it actually does with this kind is that it passes it further to the execute action function. And execute action function is the one that actually sets the kind. And this transition function actually returns the next state. This is the reason why I pass it as a variable here, because the transition already has a return value. But probably I could return the kind from this advanced token function. So I would need an additional variable, for example k. Then I can pass this k variable to the LLX execute transition, and probably to itself too. And then I could just return this k, and also I need to set the kind for compatibility to k. And then I would, if I call it recursively, I would assign the variable, I suppose. Okay, let us remove the second argument in this advanced token thing. So we just get rid of it. And then we cannot assign it, but we use this k variable, and we pass a pointer to it in the execute transition. And by use this advanced token, I just assign its return value to this kind variable. Yes, it seems to work, so let us rename this k variable to the kind again, and then compile this thing once again. And as I said, this read token variable still accepts a pointer to kind that is assigned, but does not return anything. But I want this read token function to return the whole token and not only the kind, and I will do it next time. For today, I will end it here. So we added the current global state, global tokenizer state, as local parameter to a lot of tokenizer functions. It is the first step, so that these functions do not reference the global state, but local parameter. And Then after migrating other functions that use the global state to local state, we can get rid of the global state for the tokenizer, so that we have less global variables. The most work for that is already done. So the most work was actually to fix the parser, to work with local tokenizer state, and I have just to finish and fix other places, and I'm going to do it later and not today.